Wireless Community Network. Wireless community networks, WCN, or wireless community projects, are organizations that take a grassroots approach to providing a viable alternative to municipal wireless networks for consumers. Many of these organizations set up wireless mesh networks, which rely primarily on sharing of unmetered residential and business DSL and cable internet. This sort of usage might be non-compliant with the terms of service of local internet service provider ISP that deliver their service via the consumer phone and cable duopoly. Wireless community networks sometimes advocate complete freedom from censorship, and this position may be at odds with the acceptable use policies of some commercial services used. Some ISP do allow sharing or reselling of bandwidth. History. Wireless community networks started as projects that evolved from amateur radio using packet radio and from the free software community, which substantially overlapped with the amateur radio community. Wireless neighborhood networks were established by technology enthusiasts in the early 2000s. The Red Bricks Internet Collective (RIC) started 1999 in Manchester, UK, to allow about 30 flats in the Bentley House estate to share the subscription cost of one leased line from British Telecom BT. Wi-Fi was quickly adopted by technology enthusiasts and hobbyists because it was an open standard and consumer Wi-Fi hardware was comparatively cheap. Wireless community networks started out by turning wireless access points designed for short-range use in homes into multi-kilometer, long-range Wi-Fi by building high-gain directional antennas. Rather than buying commercially available units, some of the early groups advocated home-built antennas. Examples include the Cantenna and Rania, an optical link that can be made from a smoke flue and LED. The circuitry and instructions for such DIY networking antennas were released under the GNU Free Documentation License GFDL. Municipal wireless networks, funded by local governments, started being deployed from 2003 onward. Early community projects. Early project in rural areas. In 2000, Net was founded because commercial internet service providers did not build a broadband internet infrastructure in rural Catalonia. Net was conceived as a wireless mesh network, where households can become a node in the network by operating a radio transmitter. Not every node needs to be a wireless router, but the network relies on some volunteers being connected to the internet and sharing that access with others. In 2017, Net had 23,000 nodes and was described as the biggest mesh network in the world. In 2001, BC Wireless founded to help communities in British Columbia, Canada, set up local Wi-Fi networks. BC Wireless hobbyists experimented with E800 2.11 wireless networks and antennas to extend the range and power of signal, allow bandwidth sharing among local group members, and establish wireless mesh networks. The Lac Seul First Nation communities set up their Wi-Fi network and constituted the nonprofit KNet to manage a wireless network based on E800. Cooperation between community networks. For the most, early wireless community projects had a local scope, but many still had a global awareness. In 2003, wireless community networks initiated the PICO Peering Agreement (PPA) and the Wireless Commons Manifesto. The two initiatives defined attempts to build an infrastructure so that local wireless mesh networks could become extensive wireless ad hoc networks across local and national boundaries. In 2004, Freifunk released the OpenWRT-based firmware FFF for Wi-Fi devices that participate in a community network, which included a PPA so that the owner of the node agrees to provide free transit across the network. Technical approach. There are at least 3 technical approaches to building a wireless community network. Cluster advocacy groups, which simply encourage sharing of unmetered internet bandwidth via Wi-Fi, may also index nodes, suggest uniform SID for low-quality roaming, supply equipment, DNS services, etc. Wireless mesh network, technology groups which coordinate building a mesh network to provide Wi-Fi access to the Internet. Devices infrastructure. In 2013, the Open Technology Institute released the Commotion Wireless Mesh Network firmware, which allows Wi-Fi-enabled mobile phones and computers to join a wireless community network by establishing a peer-to-peer network that still works when not connected to the wide area network. Firmware. Wireless equipment, like many other consumer electronics, comes with hard-to-alter firmware that is pre-installed by the manufacturer. When the Linksys WRT54G series was launched in 2003 with an open-source Linux kernel as firmware, it immediately became the subject of hacks and became the most popular hardware among community wireless volunteers. In 2005, Linksys released the WRT54GL version of its firmware to make it even easier for customers to modify it. Community network hackers experimented with increasing the transmission power of the Linksys WRT54G or increasing the clock speed of the CPU to speed up data transmission. Hobbyists got another boost when in 2004 the Open Wireless Real-Time OpenWRT firmware was released as open-source alternative to proprietary firmware. A Linux-based embedded operating system could be used on embedded devices to route network traffic. Through successive versions, OpenWRT eventually could work on several hundred types of wireless devices and Wi-Fi routers. OpenWRT was named in honor of the WRT54G. The OpenWRT developers provided extensive documentation and the ability to include one's own code in the OpenWRT source code and compile the firmware. In 2004, Freyfunk released the FFF firmware for wireless community projects, which modified OpenWRT so that the node could be configured via a web interface and added features to better support a wireless ad hoc network with traffic shaping, statistics, internet gateway support, and an implementation of the optimized a Wi-Fi access point that booting the FFF firmware joined the network by automatically announcing its Internet gateway capabilities to other nodes using ALSR HNFR. When a node disappeared, the other nodes registered the change in the network topology through the discontinuation of HNFR announcements. At the time, Freyfunk in Berlin had 500 Wi-Fi access points, and about 2,200 Berlin residents used the network free of charge. The Freyfunk FFF firmware is among the oldest approaches to establishing a wireless mesh network at significant scale. Other early attempts at developing an operating system for wireless devices that supported large-scale wireless community projects were OpenMesh and Netsukuku. In 2006, Meraki Networks Inc. was founded. The Meraki hardware and firmware had been developed as part of a PhD research project at the Massachusetts Institute of Technology to provide wireless access to graduate students. For years, the low-cost Meraki products fueled the growth of wireless mesh networks in 25 countries. Early Meraki-based wireless community networks included the Free the Net Meraki Mesh in Vancouver, Canada. Constituted in 2006 as legal cooperative, members of the Vancouver Open Network Initiatives Cooperative paid $5 per month to access the community wireless network provided by individuals who attached Meraki nodes to their home wireless connection, sharing bandwidth with any cooperative members nearby and participating. Community network software. By 2003, the Sydney Wireless Community Project had launched the NodeDB software to facilitate the work of community networks by mapping the nodes participating in a wireless mesh network. Nodes needed to be registered in the database, but the software generated a list of adjacent nodes. When registering a node that participated in a community network, the maintainer of the node could leave a note on the hardware, antenna reach and firmware in operation and so find other network community members who were willing to participate in a mesh, 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 in a mesh. Organization. Organizationally, a wireless community network requires either a set of affordable commercial technical solutions or a critical mass of hobbyists willing to tinker to maintain operations. Mesh networks require that a high level of community participation and commitment be maintained for the network to be viable. The mesh approach currently requires uniform equipment. One market-driven aspect of the mesh approach is that users who receive a weak mesh signal can often convert it to a strong signal by obtaining and operating a repeater node, thus extending the network. Such volunteer organizations focusing on technology that is rapidly advancing sometimes have schisms and mergers. The Wi-Fi service provided by such groups is usually free and without the stigma of piggybacking. An alternative to the voluntary model is to use a cooperative structure. Business models. Regulation. Certain countries regulate the selling of Internet access, requiring a license to sell Internet access over a wireless network. In South Africa, it is regulated by the Independent Communications Authority of South Africa, ICASA. They require that WISPs apply for a VANS or ECNS/ECS license before being allowed to resell Internet access over a wireless link.